Hi, I'm Rob Nizell. I'm the CEO of CAT.
And I'm Matt Stratton, Director of R&D.
Today we'd like to talk to you about the 3D Systems Projet MP3500 series printers. This printer is designed for model printing, and we're really excited about it for a few reasons, but it's got some really nice breakthroughs that we believe make this printer much more accessible to laboratories for printing digital models. There are a couple of reasons for those breakthroughs, but the economics are obviously a very important factor in digital model production, but also the final product is much easier to get consistent accuracy, and the quality of the surface is very stone-like, which is great for the technicians who will be working with the models to be very comfortable with these cases. So with regard to the consistency of accuracy, which is a critical aspect, everybody would look for that in their own model room. We would obviously expect that from the printer. And maybe Matt, you can talk a little bit about the differences between steering accuracy with this printer versus others.
Right, so some of the other model printing solutions kind of require constant adjustment to the actual calibration parameters of the system. So you might take measurements from one build to help steer accuracy on the next one, and so on and so forth. This machine is great because we set one set of values up front, and every print that's the same values, and we get the same consistent accuracy each time. So it's really low maintenance and a nice consistent process.
Great. If we take a closer look at this model, just to kind of see what kind of quality we're looking at, we see that it's got a very opaque material here with a matte finish. And what we've seen in other additive technologies is typically those light cured materials tend to have a somewhat translucent surface and somewhat shiny surface, which is very difficult to read, and can really make technicians have a difficult time working with those models. So we really love the look and feel of these models, and obviously the accuracy is an ante into the game to build digital models. So what we'd like to do is actually walk you through the process of building these models, what it takes to get them into the printer, and then the post-processing for getting them ready to work with. And I think you'll also find that the post-processing steps for the MP3500 series printers with this great material is a very straightforward process to get a great final result. And then what we'll do is do some comparative analysis of the output of the final product and compare that to the original file to show you how accurate these models really are. So with that, let's get started.
All right. So we'll take a look at how we actually set up the build plate and send it over to the machine. Okay, so now we're going to look at how to actually set up the jobs that we can send over to the printer. For today, I'm going to be showing you the tool that 3D Systems provides with the printer called the Client Manager. This tool basically allows you to manage your printers, check the status, and set up jobs for them. So what I'll do is double-click our MP3500 icon here, and that'll load up our kind of main setup window. I'm going to create a new job, and now I'm going to choose the STL files that we want to include. In this case, I have a whole bunch of demo models that we want to fill the platform with, so that'll just take a second to load here. Once those come in, we are going to click the preview button, which will bring up the actual modeling program. And this software does a decent job of kind of auto nesting parts, but in this case I have so many it's a little too overwhelming for the software, so I'm going to have to do some manual work here to position these. So this is going to be sped up a little bit so you don't have to watch the whole entire process, but ultimately you have full control over how these get oriented and placed on the platform. So here is our finished platform with the parts nicely arranged. You can see you can put the dies inside of the full arches, which is nice. Basically all we do here is click submit. And there's very little calculation time that you have to wait for. This pretty much goes directly to the printer, even a platform of this size. Okay, so we've nested up our platform and sent it over to the machine. So let's get this loaded up, and we'll just take a little tour through the system as well so we can see what all the components are. So we've got our clean build plate here, and this is just going to slide right into the machine. Basically open this little trap door here, slide the plate in. There's just a little groove in the front and back to lock it in place, and that's all there is to it. Just inside the machine, you're going to see this platform is going to roll backwards. It's going to deposit a layer of wax or part material depending on where it is in the build. And there's a little planer that basically makes sure everything is perfectly level for the next layer to be deposited. And that'll repeat again and again until the parts are fully built. So we load that up, shut the door. Just to give you a little more of a tour of this machine, the second drawer here has all of our wax and part material canisters. You can see we have 2 of each type. So 2 wax, 2 part materials, which is very nice because one can fully run out and it'll swap over to the next one during the build. And you can even swap these out during the build as well, which is nice. They're kind of hot swappable, so you can make sure you have enough material even if you didn't start the build with enough to begin with. Down below here, this is just the drawer to collect any wax residue that's left over from the print. So when the planerizer comes and shaves off material, that'll end up draining down into here, which is just a little tinfoil collection basket, and it makes disposal very easy. So you can see a very clean workflow here. So let's take a look over here. We have our computer control screen. And what we're just going to do is indicate that this machine is now online. It's going to ask us, is the platform empty? Yes, it is. We've already sent the job to the machine, but one thing it's asking us to do is make sure that we have enough room for the excess wax to dispose into. So we already looked at it, but we just need to basically open this door, check that we have enough room in our collection basket, and close it. Then the machine is going to go through some initialization steps, cleaning the print heads, and the job will commence. So we'll check that out. We'll see a nice time-lapse video of this job being done. It should look pretty cool. Alright, our job is all complete now. It's been about 6 hours, which is about average time for a job like this. It's all based on the height of the parts, but this one took about 6 hours. Come in here, we're going to release the latch and pull out the build plate. This slides right out, and you can see our nice full plate here of finished parts. They look beautiful. Now we can walk through the steps of how we actually post-process these into the final product. So let's get these parts off of this platform. It's a little peculiar process, but basically we're going to break off these dies by hand to start off with. And these can just be kind of broken off with a little pressure with your hand. The easiest way to get these parts off of the platform is actually to smack it on the ground. So let's take a look at how we do that. So we're just going to come down to ground level, Try to get it nice and flat to the ground and give it a few whacks. You can see it might take a couple whacks to get all of them off. Luckily the parts are very resilient, so there's not really much risk of damage here. Looks like we got some stubborn ones. There we go. Nice clean platform. Alright. Cool. So now we're going to go into the other room and throw these in the oven. We're in our post-processing room, and we're going to throw these parts into the oven. You can see we have this oven from 3D Systems. It's set to 75 degrees centigrade, which is the correct temperature to melt the support material off of the parts. Take a look inside. So as you can see, we've just got a grate here where the parts are going to rest. And there's a collection basin for any wax that drips off of the parts to collect. And in the back you'll notice a Pyrex container containing some vegetable oil. So that's going to heat up to 75 degrees Celsius with the parts, and we'll basically dump the parts in there afterwards to clean off any of the remaining wax leftovers. So first step, we're going to take our dies here. These can sometimes be small enough to actually fall through the grate, so we put them on a piece of paper towel just to make sure that they don't slip through. And we'll rest this right on the grate. Okay. Now we can take the rest of our parts and just place them directly onto the grate over the basin. Alright, so they're in the oven. We're going to close this door and wait about an hour for all the wax to completely melt off of the parts, and we can walk through the remaining steps at that point. See you in an hour. Okay, we're back. The parts have been in the oven for about an hour and all the wax has been melted off at this point, so we can pull them out and perform the rest of the post-processing procedure. So let's take a look in our oven. You can see all the parts are there, all the support material is basically melted off. There's going to be a little left over on the parts, but we'll take care of that. We're going to utilize the oil that we've had in there as well, which is also heated to 75 degrees Celsius. So basically what we're going to do is take a few of these parts, dump them into the oil, and we're just going to demonstrate right now with a few of the parts, just so we can get through this process pretty easily. So take a full arch and a quad, put them into the oil. This container is going to be a little hot, so I'm going to use a towel and pull it out of the oven. We'll keep the other parts in there so they can stay at the correct temperature. Now we're going to come over here and basically just want to agitate these a little bit just to assist the remaining wax material to get off the parts. Doesn't need to be in there for too long, but you do want to make sure that you get as much off as possible. So I'll just stir this around a little bit. Now the next step, what we're going to do is, if you look over here, we have a container containing isopropyl alcohol that's sitting in kind of an ice bath. And the purpose of the ice is basically to keep the alcohol at a cold enough temperature. What's going to happen is the models are going to be basically shocked, going from 75 degrees Celsius down to room temperature or less. And that's going to give it that nice matte finish that we're looking for. And the alcohol is also going to serve the purpose of taking off any of the oil that the parts have been sitting in. So we can just go ahead, drop these into the alcohol bath, and that'll complete, or almost complete the process. Okay. I want to give these a little stir to help any of the oil to fall off, and we'll let those sit for a minute here. We basically just want these parts to fully cool down while in this mixture. And it's really, you can start to see it now, they're starting to get that nice white opaque color. It'll take a minute for the parts to fully cool down, but this is really the process where that matte finish is going to occur. Alright, so we've dried off our parts, and the last step is to put them into the dye mixture. So basically we have a container here with, again, some isopropyl alcohol. as well as a few drops of this wood dye. Actually, it's a very effective dye. You only need a few drops in the alcohol and the model will take on whatever color that we put in there. So these come in all varieties of colors. We've chosen the dark vintage maple as for a nice beige color for the models, but you could really use any color you want. So we'll just take our parts and drop them into the dye solution. Basically, we're just going to let these sit here for a couple minutes, and once they come out and dry off, we should have a nice finished product. Okay, so our models are now out of the staining mixture and they're all dried here. So basically, we've got our final product, more or less. Last steps here are to assemble the dies. So we're just going to slide these into the model. We got our two anterior teeth. We slide down nice and snug. And so we have our full model kit. It's ready to go. We're going to do a quick scan just to check out the accuracy of these parts, and we should be good to go. So let's go do that. Okay, so we want to look at the accuracy of the models that we've just produced. One step that we didn't show you right here is we took the models that we just printed and showed you and scanned them in the 3Shape scanner. And now basically we're going to take that scan data and compare it back to the source data that we sent to the machine and see how they compare. For this purpose, we're going to use a tool called 3Shape Convince. This is a utility that's available from 3Shape that allows you to do just this purpose, which is comparing two 3D models and seeing where they differ. So basically I'm going to come in here, I'm going to load my reference part, which in this case is the source data that we sent to the printer. Now I'm going to load in the scan of the model that we just did in the 3Shape scanner, and this will bring in that scan. Now basically what we have to do is align these two models. So what we're going to do is define 3 points on each model that will help the software match these up in 3D space. So as you can see, I'm rotating around, choosing the same points on each of the models, and once this is complete, the software will know at least roughly how to align these two. So you can see them kind of converge right there. Now we'll click the Optimize, which will basically try to do a best fit at this point to bring those two together. So once we're done with that, now we can bring up our heat map. And this is basically a color-coded diagram showing us how far off certain parts of the model are from each other. We're working on a scale where everything that's green is within 50 microns of the source data. So you can see we have very good dimensional accuracy across the entire arch, especially, you know, this cross arch as well as the contact regions are pretty nice. Maybe some of the cusp tips are a little short, but ultimately for our purposes this is going to be a very accurate model to work with. Okay, now to make sure we've covered all our bases, we're going to look at the accuracy on a single die that we've just printed. So we're going to walk through the same steps in order to analyze the die. So first off, we're going to load the actual data that went to the printer. Okay, now we're going to load in our model scan of that die that came off of the printer. Okay, and we'll go through the same alignment steps that we did with the full arch by designating the 3 points on each model that will help the software align them together. So I'll just take care of that. Okay, software brings the two together nicely. We'll click Optimize here again just to get it to that final best fit of the two. Click Done. And now we can bring up our heat map showing us any differences. We start off with the 50 micron, and basically everything is within our 50 micron band. So why don't we drop this down a little more? We'll bring it to 35 microns. So everything that's green is plus or minus 35 microns. So you have a couple areas of orange, which, at least in the case of dyes, is a good thing. If anything, that'll be a little cement gap, but it's at such a small scale that it's not going to really impact the fit anyway. So regardless, I'd say that we're getting pretty good results off of this printer, and something that everybody should feel really comfortable working with.